Hello and welcome to this tutorial about Pong. Now, I've already set up the 2D game here and I've already set the scene, changed the name to Pong. So hopefully you can get yourself to that point by yourself. And from this point on, let's set up the camera. So the camera's already in our scene and we're just going to come over to our inspector and just change the color. And we'll go with the traditional colors of Pong, black and white. And I'll just click on make that black there. We'll leave the size the same, so that's good enough for the camera. Next, let us make the ball. So going back to like we did in Snake, we are just going to come down and add a 2D object or sprite, and in this case, I'm going to add a square. Now the square we'll leave as white. Its size is a little bit too big, so let's scale it on all axes here to 0.25. We'll also come down and add some components. Two things that we need to add. One is the box collider. Let's do that first. So we'll add a box collider 2D, and we don't have to do anything with that at all. That's okay just as it is. And then the second thing that we'll do is add a rigid body, because obviously this is going to be a moving one. Whoops, rigid body. Where is it here? Rigid body, there we go. I guess I have to spell it properly. There we go, rigid body 2D. We're going to leave it on dynamic this time because we're actually going to use the some of the physics that's involved with it. We're not just going to set it to kinematic. We will, on the ball here, I think we'll keep it at 1 for the moment. We'll get rid of all drag so that the ball doesn't slow down. And what we're going to do is get rid of the gravity as well because we don't want it falling out of our scene. We don't really have gravity in Pong. And I'm also going to come down to the constraints and just make sure we freeze the rotation. We want to keep the X and Y. It's obviously going to move in those 2 dimensions, but we don't need it to rotate. And that should be all for the ball, except giving it a better name than square. And so I'll call it ball there. So it should be in our scene. Let's just check our game here. There it is. And we have our ball. Second thing we'll do, I guess third thing, is set the paddles up. And so we're going to do a few things here with the paddles, but same idea as with the ball. Come under game object, create a sprite. We'll make a square. Now this one's off center a little bit. We might as well just reset that. We'll have to move it over to the edge anyways, but we'll reset that. We'll keep it white, but obviously our scale here is going to be a little bit different. So from that, I think we're going to narrow it down a little bit and then also make it a little bit bigger. So 1.5. There we go. Whoops. It should be 1. My one's not working very well. 1.5. And this one, I've got the proportions on, so let's just stable that. It seems to cross over, so this should just stay at 1. So here, sorry, this was supposed to be 0.2. There we go. Looks a bit more like a paddle. And obviously its position isn't very good, so we might as well move that over. We'll just move it a little bit to the left. So there it is. One thing I'm going to do as well is set this instead of free aspect, set it to 16 by 9, just so we can sort of see the edge. 16 by 9 being your typical sort of TV size nowadays. So I'll just set that there. Okay, so we've got it -8, so it moves it to the left. And then we've got the 0.2 just to make it a bit thinner and 1.5 to make it taller. We'll leave the sprite renderer as it is, but this one, because we're moving it as well, we'll add the rigid body. On this one, we'll take off gravity because we don't want it falling. We will also freeze the rotation, and we might as well freeze the X movement. The paddle is going to be static, unless you change it later on. It's going to be static along the x-axis. It's not going to move left or right. We will get rid of angular drag. It shouldn't be rotating. That's to do with sort of slowing it down if it starts to rotate. We're going to play a little bit with the mass here, and you can change it up after, sort of as you fine-tune it. This will make it a little bit easier to move. The linear drag will sort of make it slow down, so it doesn't just keep going, and we'll set that to 2. I think that's good for the rigid body. We just need to also add a box collider 2D, and we shouldn't have to do anything here. This should match up the size properly. We can see that in the scene. We zoom in, the box collider looks good. Yeah, so we'll just keep it like that. Okay, this time we're not doing is trigger simply because we are actually going to be using the physics to bounce this ball around. Now, square isn't a good name, so I'm going to call this player paddle. And once I've done that, I'm going to duplicate it. So the easiest thing is right click down to duplicate, and we have player paddle 1. Let's call that computer paddle. So this will be our AI. And everything's the same, so it's pretty easy here, except we just have to change its position. So instead of -8, +8 should move it across the screen. There it is. And if we look in our game here, it looks pretty good. So the ball's centered. We've got our two paddles for our game here. And yeah, that's almost it. Now, if you want to, you can put in a center line. There's a couple ways to do it. You could put it with game objects and put it in. You could also go ahead and create a line with a line renderer. So you could create an empty and then use the line renderer. You'll have to figure that out a little bit, but you can create a dotted line with a line renderer. That would probably be the least, I guess, intensive solution to that, because the line render is pretty efficient there. All right, last little bit sort of for our setup, because Pong is a pretty simple game. We need to make sure that we put some walls around here. And so these are just going to be kind of hidden walls. Unlike our snake game, which we could view them. It's just going to basically sit on the outside here. So we're going to create a couple walls, top and bottom, left and right, I guess 4 walls in total. And those will simply be empties. So I'm going to come in here, right? And you can always, game object or the little plus, whichever one you prefer. I'm going to create that. Let's make this the top wall. We'll identify them here. And for the moment, I'm just going to set up the property, reset that. I'm going to add a component. All we need to do is add our favorite friend, the box collider. And on that top wall, like I said, we just need it right along the edge here. And I think I've got that at, on the Y there, 5.5. Yep, that just right on that edge there. And then we can just extend it out on the x-axis. And I think what I did there was about 20. And don't worry about it going over the edge. That should be fine. We just want to make sure it, it doesn't do anything weird, so that should be good there. Yeah, that's it for that, because we don't want it's going to bounce off, so we'll keep the is trigger on. We'll just duplicate that one, Control D, and now you've got, let's call that bottom wall. And all we have to do is, instead of the Y being positive, we'll set that to -5.5. And again, you might just want to double check, but yeah, it's right there. Good. You could create a new empty and so on to create the sidewalls, but I'll just duplicate this one, Control D. Obviously, in this case, we'll just set it back to 0, 0 on here. This, we'll set that back to 1 on this. We have to increase the y-axis. So I think on the y-axis here, I set it to, 12 on there. I think that's good. Yeah, just a little bit high, which is fine. And then we can go over on our y-axis because we have to shift it to the left. And I found about -9.4. Whoops. Not the y-axis. That should still be 0. So on the x-axis, we want to shift it to left. So 9.4 works out perfectly. Okay. And we'll do the same thing after we rename this. So I guess this was the left wall. There we go. And I'm going to Control D. And that's going to be our right wall. And so once that's named, we should move it as well. And again, because this is symmetrical, it should be 9.4. Okay. There we go. And just to see them all, there it is. Okay. And that looks pretty good. I don't think we have to worry about anything. So let me double check there. The left walls. Yep, they're all just on the outside of the camera. Obviously, we can't see it in our game, so it doesn't really matter. But the idea is that when it hits the edge, it hits the wall. If you want to design it a little bit differently, feel free, but that sort of sets up our base game here. I would suggest maybe grouping these together just to keep things a little bit neater, a little bit of housekeeping there. And otherwise, I think we're pretty good. So we got to do the scripting next, and we'll start getting the scripting for the paddles there. All right, let us start doing some coding here. So before we venture too much into coding, let us create a folder to hold our scripts and create our first C# script. I'm going to go in there, right click, create a C# script, and this one we'll call paddle. We're going to do something a little bit different here because we're going to have two paddles, but what we're going to do for the first paddle, or sorry, for the paddles, is create a base class, because the computer paddle and the player paddle will inherit or sort of share some of the similar sort of characteristics. So instead of coding it twice, we'll create a base paddle script, and then we can reference that paddle script as we build our player's paddle and our computer paddle. So create a paddle script first, and let's start to edit that. Just open this up. And I'll allow access here. And we'll start off with our paddle. So just make sure your paddle and your paddle are the same names there. And what we want to do with this is basically create a couple variables. Ooh, I don't know why we just went off. Let me just give me 1 second here. That's better. Back in dark mode. So then we've got at the very top here, we'll put in a couple variables, and those little variables will just sort of hold two things. And one thing that they'll hold is the speed. So we want to be able to maybe update the speed here. So I'm going to keep this public, and we'll call it, will be a float, because maybe we want decimals there, and speed, and we can initialize a value. Let's just call it 8. Okay, and we put an F there to make sure that it knows that it's a float. And the other thing that we'll do, and this one doesn't need to be, well, we'll keep it here. We'll keep it public. I guess make it easier. And we'll do a new rigid body. So this is going to be a rigid body 2D. And usually I call it RB2D. Okay, so we keep those there. And then we'll change from start to awake. And I'll explain in class why a little bit of a difference there, or you can look that up as well. So in the awake here, we'll just grab the reference to that component. So we created we created it here, but it doesn't know what it really is in the game. So we need to RB2D equals, it's all there for us, right? So we're going to grab that rigid body component and then be able to manipulate it there. The other thing that we'll do, this one won't have any updates going on. We're not going to do any of the key grabbing or key input here. So what I'm going to do is just change this name, and we'll call it the reset position, because we'll need to reset the position of the paddles when, maybe the start of the game, probably. Maybe if you want to reset at, the serve as well. So this will be often called. So what we're going to do to reset the position, and this already is here for us. Life is pretty good, although we don't need to worry about the x-axis, or sorry, the z-axis. So let's just make that vector 2, 0. So basically what this is doing is referencing on the rigid body. The rigid body keeps track of the velocity on all three vectors. And this here, a little bit of a shortcut to say set all the vectors, well, x and y here, to 0. Okay, we could have done it with the vector 3. It wouldn't have made a difference. The other thing that we want to do is reset the position as well. So this one, a little bit different because we don't want it back to 0. So RB2D.position, right? We don't want them sitting in the center, so we can't do what's suggested here. What we'll do is we'll do a new vector 2, and the positions here, it should be already there. So the RB2D dot position dot x. So it's the original position because it shouldn't move off of that. Again, this might be different for if you modify the game at all, but as far as I can tell, even looking forward, it should be there. And then the other thing would be on the Y, we'll keep it to 0. So this creates a base class. And like I said, this class here is going to be used by both the player paddle and the computer paddle. Okay? So I've saved that. It's not going to do anything. We could start to, well, we won't even try using it here. But the big thing is making sure I do have something, a warning. What's showing up here? Paddle RB2T does not hide new key. Yeah, that's what I wanted there. I don't think I need a new. So let's just get rid of that. There, that gets rid of that. I think that was just the warning. So no issues found. We'll save that up. Yeah, we don't need to. It's just going to create a reference to it, and we'll see that in the game. Okay, let's go back to Unity and actually create our player paddle script. So I'm going to come over here, create C# script, and we'll name it right away, player paddle. Spell paddle right. And I'm going to open that one up. Now, this always here, you see, and you might have wondered what this mono behavior is. That means it inherits from Unity's sort of all the stuff that has sort of to do with Unity, basically. In this particular case, we're going to inherit from that paddle script. Now, the paddle script already inherits from mono behavior, so it inherits from mono behavior, everything that we need there, and also the stuff on the paddle. So this just makes things a little bit more efficient. We don't have to duplicate the code again, because the stuff that, like I said, for the speed and also the position, right, we need to have that on both paddles there. So what I'm going to do is just create one variable. Let me get public here for the moment. It'll be a vector2, and it will be the direction, just like we had in Snake. Okay. And in the start, I don't think we need anything because we'll be able to, that will run from the paddle already. We'll just go to the update, and the update is where we're going to grab, as usual, our movement, or our keyboard input, I should say. So we'll do it very much like we did with Snake. So if input.getKeyDown, and this one, the key code, I'm going to do 2 this time. So keycode.w. Okay, so that would be our up. But I'm going to put an OR here, and the OR is the 2 straight lines. So that means OR in C# programming. And that OR, those 2 straight lines just above the Enter key on your keyboard, you have to hold Shift, sort of on the same key as the backslash. And so I'm going to do, oops, oh, yeah, that's right, input.getKeyDown, get key down. Oh, I guess I could type a little bit more, get key down. And then this one, we'll do the key code, and we'll use the dot up arrow. Okay, so up arrow, there we go. So if we do that, just make sure, one more of those, I think we're good. Good, and we'll put that in into a braces there, just in case. And so we'll set the direction to direction equals vector2 up. Vector2 dot up. Good. All right, so that should get us moving our paddle up. To save me a little bit of, I can get this over here, to save me a little bit of time typing, I'm going to copy that, because basically to move down, it's going to be identical. The only thing is I'm going to put an else if here. And so now it's get key down, and then we'll do the S as S, or obviously the down arrow. Follows the same pattern. And then the direction will just be vector2 down. And last thing, we'll just put a little bit of an else on here, just to make sure that, if anything else is sort of pressed, what's going to basically do is make sure that the direction is equal to vector2 0. Okay, we'll just there we go. So that will just sort of be a thing to make sure if we're not pressing the keys, sort of there's no direction being set. So that's good for the update. Now, as you remember from Snake as well, anytime we sort of deal with physics and movement, it's often good to use the fixed update. So I'm going to use void and a fixed update. There it is, it's suggested. Now it puts it private. It makes private, which is fine. We'll just leave it on that. And I mean, if we want to keep that sort of consistent, we'll make that a private as well. So fixed update, this is where we're going to update the direction. So this is a little tricky thing here, but this will make sense. If the direction dot, we're going to square the magnitude, I'll explain this in a second, does not equal 0. If the direction is non-zero, we are going to add a force to our object here. And so what we do is we access that rigid body 2D, and notice that RB2D, even though we didn't define it here, is available. And it's available because it's coming through the paddle class. So RB2D dot add force, we're going to push it basically, and that looks good. Direction, oops, Control Z, can I go back to that? Oh, it's not good. Okay, direction, yep. Okay, anyways, I'll type it in, direction, and we're going to do a little bit of a difference here. We're going to be able to multiply it by the speed. There we go. So this, in theory, once we put everything onto our paddle, should work here. So let's just take a look. Got no errors and warnings. Everything looks good. I'm going to save that. Let's go and see if this works in Unity. Let it compile and upload those scripts. And then we're going to go on to our player paddle. And we don't have to include the paddle one. We do have to include the player paddle one. So I'm going to drag that on. You can see here we've got that speed that it inherited from the paddle set to 8. And we can hit play. Obviously the computer paddle is not going to move. Let's just see if the other one. So I'm going to use the W and SD. Now it is moving at a very, very, very slow rate here. So something's a little bit wrong. We can see that's going there. It's a good teaching moment here. So what did I do wrong? Well, it was moving, so things were looking kind of okay. Trouble is, in my code here, and maybe some of you caught it, it shouldn't be get key down, because that would require me to constantly push it. So what it should just be, I apologize, is just get key. And so get key, you can just sort of hold the key down, and in this case, the paddle should move there. So just make sure all of those are get keys rather than get key downs. And like I said, we learn from our mistakes. So there we go. So let's just bring that back in, reset the play here, and hopefully, looking better. Now, we can refine the movement of this and make sure as we play, but for the moment, yeah, it seems to be pretty good. Okay, so let's just sort of work on next creating the computer paddle script. The computer paddle script we'll create right now. So create and C#, and we'll call this computer paddle. Now the difference is obviously it won't have anything to do with keyboard inputs. What we need to do is basically create a simple AI that will know where the ball is, and if it knows where the ball is, it can kind of position itself based on that. Now there's a few things that we can do. One thing is that we'll get the paddle to sort of reset its position when the ball is moving away, so it sort of head back to the center. And then the second thing that we'll get it to do is, obviously when the ball comes toward it, so it's heading towards the right, I guess, we will get the ball or the paddle to start moving. So that's kind of the logic here. So the first thing that we need to do is we need to get a reference to the ball itself. And so we'll make that public, and we're going to actually just make a direct thing to its rigid body. So we're going to grab the ball's rigid body, and that will allow us to sort of see a few things. We don't need anything in the start, so let's just get rid of that. I guess we'll get rid of all this. And our update, well, let's get rid of that, and let's just go into our fixed update here. Let's make that fixed update. So make sure it's changed just blue because, you capitalize the F there. So what we'll do, like I said, is position the ball based on, or position the paddle based on the direction the ball is headed. So I think the first thing that we'll do is if the ball's velocity, so let's just check here, so the ball dot velocity, so again we can grab that off that dot x, so we're only interested in the x direction. If it's greater than 0, so that will mean, let's just do that, greater than 0f. That means it's heading towards the right, okay? So if we have a positive velocity on it, so what we'll do is we'll take the, basically, if the ball's position dot y is, let's see here, greater than the paddle's position on the y, then we're going to sort of move it up, right, to match where the ball is. So basically the paddle will be below, and then the ball above, we need to move the paddle up. Now, one thing I forgot to do right here is that we need to inherit from mono behavior. So I'm going to set that to, sorry, not from mono behavior, but from the paddle. So we're going to do that. That will allow us to access this object, right, the paddle's rigid body 2D dot, we want the position dot y. Okay, so if the position, basically the ball is above, we need to move that paddle up. So then the RB2D, so that's the rigid body on the paddle, dot add force, and then we're going to do by vector 2 dot y, and then we'll times that by sorry, so vector 2 dot, sorry, up, thinking on the up axis, and then we'll times that by the speed, right? And semicolon there. So basically we're going to push the paddle up towards the ball, and then we have to do sort of the opposite as well. So I'm just going to copy this, do this, and we'll do an else if here. So if it's the opposite, so if the ball is below, so it's less than the paddle's position, then we're going to do this down. Okay, so just some pretty basic logic there. Now this is all if the ball is heading towards us, okay? So if I'm just sort of come down here a little bit, this, like I said, this is all if the ball is coming towards us. We want to move the paddle towards the ball. Now if the ball is going away, so that would be the opposite. So let me just make sure here. I've got, sorry, this guy. Let me just move that back up. Okay, there we go. So this here, to match up with this level, this is going to be our else. So it doesn't need a condition, because either it's moving away from us or it's not. So I'm going to put that in there, give us a little bit of space, and then we're going to almost do the same thing. So I'm just going to copy this, I think, again, and just modify it a little bit. So basically, if the paddle's position is, we'll just keep this, greater than 0. So basically, if the paddle is above the middle spot, we'll move that paddle down. Okay, and I'll just copy this here. I mean, we'll do it with the else if, because if it's in the center, we don't want it to do anything. So we'll do an else if here. If it's less than 0, so if it's below 0, right, then we're going to add force and just move it up a bit. Now we can't test this out quite yet because we don't actually have the ball moving, okay? But the big thing is I don't have any errors here. Make sure that you did, like I did here, inherit from paddle, not mono behavior, and I think we're good. So I'm going to save this, just go back to Unity, make sure there's no issues, and put the script on. There it is, looks okay. I'm going to go back to the computer paddle, add the computer paddle script, just to make sure nothing's gone haywire. Looks good, okay. Now it doesn't know who the ball is. We'll fix that up after. But I think otherwise we're pretty good to go and really just need to do the ball script. So the ball script will be next here, and we'll work on that by creating a new C# script, and probably just calling it ball will be fine. And we'll open that one up. So the ball, it will inherit from mono behavior, of course, and because it's not related to the paddle, so we won't put paddle there. We're going to create two variables, something similar to what we did with the paddle. Public, we'll make this public so we can change it, or maybe the game manager, which we'll get to a little bit, could change it. So we'll set a speed here, and we'll type something in for the moment. You can always modify that later. We'll just sort of see how this goes. And then we'll also need a reference to the rigid body, so exactly like we did before. So rigid body 2D, and again, we can use the same name, so RB2D. That will be our reference there. Same thing, we won't use anything to start here, but we'll go to the awake, and just like we did before for the paddle that we moved, we have to get that rigid body. And so the RB2D, we can just tab through all that there. That will grab the rigid body so that we can access it. Right. We're going to create two of our own of our own functions. We won't have the update here. Basically, the idea is that we get the ball moving, we give it a bit of a push, and then because there's no friction, there's no nothing going to slow it down, it will keep moving throughout, as long as we need it to. So there's no need to sort of continually add a force. There's no need to control the ball, right? So that's why we don't need the update here. So create, like I said, sort of two functions, and one will be the reset position. So this will just sort of help us, when we score a point or perhaps begin the game, we might want to call this. And so what we're going to do is do two things. We're going to set the velocity. In fact, we can do that right there. Yeah, vector 2 or vector 3, 0 doesn't really matter. But we've got vector 2 there, and we'll do the same thing. Now, we shouldn't have to reset the angular velocity. I don't think we'll need to, but we'll also reset the position. And because we set it up in the middle, we'll do vector 2, 0. All right. On to our second sort of function here that we're going to create. Now, actually, I should be explicit here. If you don't say what type of function it is, it's going to be set to private. And that means you can't access this function outside of the ball script. Now, the ball isn't going to itself call reset position in the end. We're going to have a game manager do that. So we need to make sure that this is public. And we'll do the same thing here while we're at it. We'll set this one to get the ball started. We'll set that to public and void. And we'll call this, launch ball or something like that. It's whatever you sort of want to call it. Not a big deal, but that's what I'm going to call it there. Launch ball. Not lunch ball, launch ball. So what we're going to do is we don't want it to always launch the same direction. So we're going to create a little bit of variability here. So we want it to be going, either left or right, and then we want it sort of to be going, at a different angle, basically. So what we have to do is kind of create a force to push this ball in a certain direction, and we can, like I said, vary how much it's pushing it sort of in the X and in the Y. So the first thing that we're going to do is basically determine what our X and Y directions, our vectors, are going to be here. So we'll create two variables. We'll do the X first, and then there'll be quite a bit of similarity with the Y. What we're going to do is use random, and there is a random here, a built-in random.value. And we're going to, this would just give us sort of value. We could create a range, but we're going to do something a little bit special. So by random.value will give us a value between 0 and 1. So what we can do is we can actually say, well, if the value is less than 0.5, this is a little bit of interesting scripting here, we can ask a question. And we can say that if it sort of if this is true, if it's less than negative 0.5, we'll set the direction to -1. So that will move it to the left. Or, and that's sort of this colon here, we can say if it doesn't do it, what's the opposite, right? Sort of the false here. We'll set it in the other direction. So 1f. Okay. So just to sort of clarify this, because it's a little bit different, we're creating an x value that's going to be part of our direction, which you'll see in a minute. We randomly generate a value, so between 0 and 1. If that value, okay, and then we're going to check this value to see if it's less than 0.5. So that's sort of where that question is. It's like, is this value less than 0.5? If it is, it will set the value to -1. If it isn't, it will set it to 1. So that will determine if it's going left or it's going right. Now we'll do kind of the same thing for the y, but be a little bit different because the y has a few more, there's a bit more challenges, I guess, to it, but it's going to be the same thing. So we're going to set the y value to be this random value again. Okay, and we're going to see if it's less than 0.5. Same thing, so 50% chance basically. And we're going to ask ourselves the question. Okay, and so the same idea here. So if it chooses, so this is where it gets a little bit more complicated. So if it chooses less than 0.5, what we're going to do is we're going to launch it sort of more in the down. But we have to pick a value. And so we don't want always to be the same value down. So we're going to use another random, and this one's called random range. And so what it will do is it will pick a number between, in this case, so to go down, -1f and 0.5f. Now that order is from large to small, or sorry, smaller, the min, to the max, right? So this should be -0.5. There we go. And we've got, I don't want to put a thing there because we've got another one going on, right? So the idea here is that if it's less than 0.5, so if that one, it's going to then randomly choose some value that's between -1 and 0.5. That will give it enough of a, we don't want it too much, we don't want it too shallow. That's basically the idea here. So this gives us enough sort of angle to make it look good, okay, or make it more fun to play, I guess. And then we'll do the same thing if it goes up, right? So if it chooses 0.5 or more, we'll just sort of hit it up direction, but we have to do 0.5f. So again, there's the min, 0.5f. Okay, let's see if I can type here, and then we'll do +1f. Good, I think we're good there. So basically, the ball is either going to be heading in a down direction or an up direction. Now, it's always going to be moving to the left or right as well, and so you'll get that vector. So once we've created this direction, well, the x and y, we'll create the direction. So this will be a new vector 2. We'll call it direction. And so we can do vector 2, and it's going to be the x and y values there. There we go. And then, so now we've created sort of the arrow pointing in the direction we want. We have to actually add the force. And so I think, that's exactly what we want. The only thing that I would add here is that we need to multiply it by speed so we have some sort of control. Otherwise, this value is going to be, sort of like just 1. This gives us, we're basically multiplying that by 8. So the x value would be either +8 or -8. Or no, sorry, it was 200, wasn't it? 200. So +200, -200 on the x-axis. And then somewhere between 0.5 and -1, we're multiplying the y. So it's going to be between 100 and 200 on the y, positive or negative. Now I think that's good. No issues found. Now nothing is going to work here. So what I'm going to do, because none of these are called yet, just to see that it works, let's run the launch ball from the awake, okay? So we're not going to worry about resetting the position because the ball is right there already. We'll use that after. Whoops. Launch. Oh, I saw it popping up. Did I spell launch ball? Ooh. I got louch ball. I know. Yeah, that's better. So let's just do that. There we go. So now we should be able to launch the ball. So we really haven't done anything in this game. Let's see what happens. I guess we'll do it first. We'll just have the player paddle working. Okay, there's no way to lose this game yet, so let me just go to the ball. There it is there. I'm going to drag on my ball script. Good, it's got power. It should find the rigid body. Hit play. Like I said, the computer paddle isn't going to follow the ball yet, but now there's issues. We don't have it bouncing off the walls yet. We'll fix that too. But you can see that it randomly is headed in a different direction. Okay, that's really what we're worried about. Okay, and then I've got my paddle working. Just double check again. So that's looking pretty good. Okay, now obviously there's quite a lot still to do here, but yeah, we've got sort of, at least the ball is launching, at least our player paddle is moving, and we can pretty well assume that our this other paddle is going to work. I guess we could do a little check here. Let's just double check. Our computer paddle there. The computer paddle needs to know where the ball is. And in fact, down here, you're getting this null reference exception because the computer paddle doesn't know where the ball is. So that's exactly what this is saying. It's saying, where's the ball? Who's the ball, right? It's looking for it, but it can't find it. So we'll simply drag that ball in for the moment. Okay, hit play again. That should clear away these errors. There we go. Now, the ball was moving to the left. So if you remember from the script, the paddle will sort of center itself when the ball's moving to the left. So let's see if we can get the ball moving towards the right here. No. Try again. There we go. And it is moving up. Now it hit it. We don't have the bounciness. And then you can see how it re-centered itself. Now, it looks a bit odd. It's a bit jittery. But the idea is that it would still, the ball would eventually pop back, right? So that jitteriness would not really be as evident. But that might be something that we need to improve later on. Okay, but good. We've got kind of the basic going here. Like I said, we've got to sort of work on fixing the bouncing, which we'll do, and also, you know, thinking about something called a game manager. All right, to do the bounciness, it's a very simple process. We can add something called a physics material, and then we simply apply that to whatever we want to have that physics property. So what I'm going to do, just to keep things nicely organized, let's just create a folder, I guess, and maybe call it physics materials. We're only going to have one, but always good to keep things organized. And then open that. And if we right click here, we should be able to create, and making sure that we go into the 2D, and there's physics material 2D. Give it a name, I guess. We'll call it bouncy. And there's just two properties that you can play with. One is friction. So when it collides with something, you know, how much friction. And you can kind of get a little, there's usually a little tool tip here if you put your mouse over top. Usually it does. It's not doing that for me at the moment. But anyways, we don't want any friction. Bounciness is sort of a number between 0 and 1. 1 is maximum bounciness. The idea is you're not losing any energy when it bounces, when there's a collision, and that's what we want. We want maximum bounciness. I'm trying to remember. I think you might be able to go higher, and then that gives you, it adds energy to it. I'm not 100% sure, but you can test that out there. So what we're going to do, I think it's just good enough to put it on the ball. And you'll notice here under the material for the box collider, there's a spot there. And so we can either find it there or just it's right there. I'm just going to drag it in. So let's see if that fixes some of our problem. And we've got, good. Now it's bouncing. Okay, now there's going to be obviously a few little problems with the game, but at least the ball's bouncing now, and that's looking a lot better. Okay, let us leave this here for the moment and talk about the next part, which will be getting into the score. Now, what I'm going to do for you is get the background of the score working. And then you can do the UI. So this will sort of be a bare bones game manager that will have some of the I guess, some of the properties that we want, but we're going to do a little bit more here. You're going to do a little bit more here. So let us take a look here at making a game manager. And so I'm going to go back into the scripts. And the first thing I'm going to do, create C# script. And I'm going to type in game manager. First thing you'll notice, if you spell it correctly, is that it actually shows a different icon here. And for better or for worse, it's still a script. It can be a bit misleading that you think it's not a script. It's still a script, but it's just because it's one of those very common things that Unity has given it a bit of a special symbol there so you can recognize it. So I'm going to click on the game manager and bring this up here. Now, one thing it needs to know, well, we're going to create a few little variables here. And like I said, we'll sort of just create a bare bones implementation for the moment. Probably the most important thing at the very top here is that we're going to create a reference to the ball. And since we have our ball script, and then we'll call it the ball. We'll do that for the other two as well. I think I'll just sort of split it up a little bit here. So I'm going to do public. We'll do the paddle, which is just grabbing from that class the paddle, and I'm going to do the player paddle. And you'll see why we need these a little bit later on. What we'll also do too is, and we'll make it public so it can be accessed, int player score. And then we'll basically do the same for the computer. So I'm just going to copy these two and just change player to computer. Now they've turned red there because you can't declare two variables with the same name. There. So all we've done is kind of created some sort of a setup here. Okay. Now we're going to create a few variables, and like I said, this is sort of a bit of a bare bones implementation, and you can make it better. At the start, we'll just make sure we call our new game function. Now we don't have a new game function. Let's go make that new game function. That new game function is going to do a few things here. So what we'll do, and again, we're sort of building this. I might as well do it here. I think we can just keep it. Well, we'll do it all public here. Public void new game. And new game will have a couple things. One is we've got to set the player score. And we're going to create a function to do that. And it's going to set the player score to 0. So we've got this. We'll talk about this, how this works in a second. We're going to set the computer score. We haven't got this function either, but we're going to set it to 0. And what else should we do? We're going to have to restart the ball. And we're going to actually create a function called start round. Sorry. Okay, so we've got all these functions. Don't worry, we've got lots of errors because we've still got a lot of code to go through here. Let's maybe create the player score or the computer score. We'll do that first. So yeah, we're gonna now. Again, there's lots going on here, so it will make sense once we get some of the stuff in here. So public void player scores. So this is if the player scores. What's going to happen? Well, what's going to happen is we're going to increase this the value, right? So if the player scores, we're going to run the. Just let me see here. I'm just trying to remember because we've got player scores. Yeah. So what we'll do is we'll set the player score. So we're coming back to that function. And so in that function, we're going to take whatever the player score was and add 1 to it. Okay, so don't worry, we've still got lots of red here. We've got to figure things out. And then we're going to start a round as well. Okay. We've got that. And basically, we'll do the same for computer scores. So I'm going to copy that. So lots of stuff here. So computer scores. And we're going to create a function still, set computer score. Okay, so let's actually get the set player score and the set computer score here. And so public void. So let's do the set player score first. And it has to, you can see here, it takes a value. And that value is going to be an int. Okay, and we'll call that the score. And so when it does that, what we're going to do is set the player score, whatever the player score is, we're going to set that to the score. Okay, and we're going to, you can do this. You want to update the score text. So that would be for you to do. Okay, so now notice the set player score is good. Okay, good. So score, yeah, int score. I think we're good. Scores. Yes, because this one here will take the current score and add 1. Okay, and then that, so that puts us in there. Okay, yeah, we're good. We're good. We're good. I'm going to copy this and we'll do the set computer score. And so the computer score is here. Okay, so I think we're doing pretty good here. So what we've got, like I said, for both of these, what happens is when, and we haven't actually called the player scores or the computer scores. So that's kind of the thing that we haven't done. We'll do that with an event at a certain point here. But the idea is when this function does get called, what it will do is it will take the current player score and add 1 to it. And then so that sets the player's score. And if you look at sets the player's score, it takes that value, okay, and then updates the player score. Basically, it takes whatever this value was, which was really +1, and does that. And then it's also going to, like I said, sort of set that, update that score. Now, the other function that we'll put in here, so let's keep those together. My update's getting further and further down here, but that's okay. I'm going to sort of do the start round one. So we'll just set that public void. What did I call it? Start round. So this will be, you know, where you're playing the ball sort of thing, right? What we want to do is, well, sort of the things that we created functions for on the other. So on the player paddle, we want to reset its position. So we should be able to find it. Now, if I can't find that, we've got a little bit of an issue. And that's mostly because I set it to private. So let me just type this in first, reset position. And let's go take a look at that player paddle. So I'm just going to save the script. There's errors here, but I'm going to go to player paddle. And where was my reset position? Oh, maybe that is on the regular paddle ones, right? Reset position. And notice right here, like I said, I didn't set that to public. So this would be a situation where we need this to be public for sure. That way, when I go back here to the game manager, you can see there's no longer a problem. Okay, you can find it. We'll do that with the computer paddle as well. So I'm going to come in here, computer paddle. Okay, so it predicted it. That's no problem because it inherited it, so that's fine. Now let's just check out the ball. Can I do that? Ah, it's good. So that time I did make it public. Good. And the ball also, we'll call it right from here. We'll add, oh, that's interesting. So I didn't do that. So let me just get rid of that line because let's go back to the ball. Launch ball. Oh, I did do public. Oh, I called it launch ball. That's why. Good. So ball dot launch. There it is. And then we're good. All right. So lots and lots of code in there. I'll be sure to sort of go over a little bit with you in class. Maybe I'll just put all this up here for a second so you can review it. So there's the start. You can take a look. Okay, and pause it here. I'll come down to the next bit. So there's lots of functions we created. New game, player scores, computer scores. Okay, and then just go scroll down a little bit more. Set score, set player score, set computer score, and then start round. And I think that's it. Oh, sorry. Well, there's the update sitting there. We haven't done anything with that, but that's pretty good there. Okay, So just make sure you check your code, and hopefully there's no issues there. Now what we need to do is sort of create an event for something to happen, and then for us to be able to call one of these, specifically player scores or computer scores. And when that does, it can kind of, call that, use this function, and that kind of sets the ball rolling here. So we're going to add one more script, and that will be our basically our scoring zone script that will check to see if the ball gets past the paddle. And when it does, it will cause other scripts to run. It will, well, actually, it will go to back to the game manager and cause some of those functions that we had created earlier to actually work. Because, like I said, at the moment, the game manager is there, but it's not doing anything. Before we do that, though, we should create a game manager object to put our game manager on. So let's do that first. Just create an empty, make sure it's set to 0, and then put the script on it. So where is it here? There we go. And we can see all these different things. We'll deal with that in a few minutes. So let's put that one more script in here. So we're going to right click, create a C# script, and we'll call it a scoring zone, I guess. And the idea is that we can put it on both ends. We'll put it on the collider, the box collider there. Let's open that up and do a little bit of scripting. It's not a very long script, 5-6 lines here. And so what we're going to do right at the very top here, we've got using the Unity engine. We're also going to use the Unity engine, Unity engine dot events. And this will allow us to use the event system. Okay. And so what we have to do here is, I think we're good. Basically just create a event. So I'm going to come up into the top here where we create our variables, and we'll make it public. It's going to be a Unity event. So that's actually the type, and we'll call it the score trigger. Now this is a much cleaner way of doing this than I've done it in the past. In the past, I've sort of created separate scripts, one, detecting if it's on the left side, the right side, a variety of different things. The trigger and using an event makes things a little bit easier. You can just sort of specify the event in Unity. So again, we just have to sort of create one, basically one little script here. I'm going to get rid of all this stuff. So it just simplifies it a little bit. We're going to use we'll use an on collision enter, because we're not using triggers here. So on collision enter 2D. We can keep all that the same. And basically, we need to define the ball first. So I'm going to do, it's going to be of the type ball, because that's the function or the class we created. And I think this is all we need. So ball equals collision.gameObject.addComponentBall. That is correct. What it's going to do is basically make sure what's colliding with it is the ball. Okay, so if it can add that script to it and knows it's the ball. In this case, I mean, it's only going to be the ball really that's moving that's going to possibly collide with it, but this just makes sure it is the ball. So what we're going to do here, if the ball does not equal null. So we're just making sure that the ball was found, basically the ball script was found. What we're going to do is set that score trigger, and we're going to invoke it. And so what's basically going to happen, you're going to see this in a minute here when we go back to Unity, this will give us some ability to choose sort of what that score trigger results in, right? We're going to invoke some sort of happening after. So I'm going to save that. Go back into Unity here, and I'm going to look at my walls, and I'm going to put it, well, let's just do it the first one. Let's do it with the left wall. So that's on the player side. So I'm going to grab that scoring zone and put it over here. So I have then this score trigger sort of sitting here. Now, one thing I noticed is I left my game manager with just the game object name on it. Let's just change that to game manager as well. So the game manager has the game manager script on it, right? So going back to that left wall, so like I was saying, we need to, this is going to cause something to happen. And so what we need to do is we need to find the object that has the script on it, which is going to be the game manager, and then we should be able to find the script and then therefore the function that goes with it. So if I come under here, there's my game. Oh, I want my game manager, not my script, but the actual game manager object. So it's probably better to just drag this in. And when I go under no function, I can find the game manager script. And what you should be able to see are some of those public scripts, or sorry, public functions that we created. And so I can see the computer scores, the player scores. And I think that's the one we want because, ooh, just a second, let me think about this for a second. So on this side, we have to think about this. Actually, the computer is scoring because the player paddle is on the left side. So on the left side, the actual computer has scored. So I'm going to set that to computer scores. Okay. So basically, if the ball hits the left side, then the computer has scored. We're going to do the same thing on the right wall. So I'm going to grab that scoring zone. Okay. The trigger is empty. Add that. So the object again, drag the game manager in. Now, under your functions, choose your game manager script, and then come down to, this would be the player scores, because if it passes the computer paddle on the right side, it is now going to run that player scores. Okay, so let's see if this is kind of working. So I'm going to turn the game manager visual, okay. I think we might have to do a couple things here. Let me just see what's happening when we hit play. Because I think we need to drag these over. Yes. Now, later on, I can show you how to make it so that it does this automatically. But the moment the ball needs to be known who it is, the paddle of the player needs to be known, and the computer paddle needs to be known. So we sort of need all these things here. Okay, so that should help things out. Let's just see. So I'm going to hit play. And oh, the ball just falls straight down. It's bouncing, but it's not moving anymore. Okay, let's take a look at what's going on here. And so the problem was quite straightforward. So this is all okay. What I had forgotten is that we had play tested earlier, and we had called the launch ball, and we kind of had two conflicting things because now the game manager is calling the launch ball, but the ball was calling launch ball. So a little bit of a problem there. So let's just go back to the ball script. So if you remember back, I put this in just so that we could test if it was working. And we don't need this anymore because the game manager is going to call that. So remove the launch ball from the awake script. Okay. So I'm going to save that. And then I'll go back to Unity and make sure that you've got the ball dragged in from over here and the paddles as well. And what we're looking for here is to see if the score works out. So I'm going to hit play. So hopefully this will launch properly. There we go. So the computer, I'm going to miss this time, and let's just see what happens. Good. So there's no pause there, but you can see the computer scored a point. Okay. Now I don't know if I'll be able to score a point on the computer here, but at least, yeah, it's working. I'm going to cheat though, so I'm going to score on the back. Okay. Once this gets going back, just a second, I'm going to click on the whoops. Of course, I'm going to lose a point. Okay. So what I'm going to do, that's the computer paddle. I'm going to turn off. Well, I could have turned off something there. Just give me a second. I'm going to turn off its script. There we go. Okay. So now it's stopped. And there. Okay. And you can, I've lost. Oh no, there I go. So now you can see I'm scoring, I think. Let's just go game manager. There we go. So this player scored and the computer has scored. So it's all working there. Good. So now you've got a basic implementation of Pong. Now there's still lots to do. Like I said, the video would just take you through the basics here and then leaving you to personalize the game and also add some what I would consider sort of necessary features. So what are some necessary features that we need to put in? Well, definitely we need to make the score visible, right? At the moment, the computer is keeping track of the score, or the game's keeping track of the score, but we can't see it. So I think that would be a big thing. I mentioned earlier maybe a line in the middle, just to sort of create that center line. The game could go on forever. You can see there's not too much of a challenge if you play it. So maybe how could we make it a game a little bit better? So a couple things would be, one is, increasing the speed of the ball after each hit or after a certain period of time, so that the game gets a little bit more challenging. Otherwise, like I said, each round could theoretically last forever. The second thing that would be an important part of it would be the English on the ball. And the English on the ball means that it doesn't always bounce sort of in the reflective style it is at the moment. So at the moment, it's just using regular physics. And so if it comes in at a certain angle, it will bounce off at that sort of reflected angle. And we'll talk a little bit more about that in class. What we want to be able to do is if you hit it on the sides of the paddle, you have sort of a bit more control about where the ball's going. So we'll look at that. That's a little bit more of a tricky one, and I'll probably help you out with that. The other thing is that the game really would never end. So maybe we have a round counter, right? That's going to see how many rounds that you win, and maybe the first person to get to 5 winning rounds, they win the game, right? So that's something like that. What else could you do? Well, a few other things maybe. The ball launches right away, so maybe if there was a bit of a pause before it launched, that might be a sort of something that I think would improve the game. I think I will give you a sound that will go beep sort of as it launches. So that might be something that you could give it a second or two before it actually launches the ball after either beginning of the game and or after every point. The other sounds as well. I've got the original Pong sounds that you can find in our files there that you'll be able to use. You can go and make the graphics better. There's sort of, you can make it glow or something like that, whatever you think would sort of maybe modernize the game a little bit. I think there is a tutorial on YouTube that has glowing Pong or something like that. I've had students in the past when the paddle or the ball hits the paddle, there's a bit of a screen shake, or maybe when there's a score, there's a screen shake. Either way, whatever implementation you think works better, maybe for both. A smaller shake for the hitting the paddle and a bigger shake when the game kind of, or when someone scores. And then whatever else you can think of. One option could be, sort of like a menu system. So you have a Pong sort of start screen, and then maybe a Pong end screen that tells you who the winner is or whatever the case is. You could also have an option. We've got player versus computer at the moment. Could you somehow implement a player versus player? So you have 2 players. And so you might have to think about what you could do to change up the coding there, creating a different scene. There's different ways of going about it. So take those into consideration, and hopefully you can make Pong better than the original. So good luck with that.